All right, going on to section 2.1, which is solving equations with one variable. What I want to do is just start with just one-step linear equations, and then in example 2 we'll do two-step equations, and then we'll go to multi-step equations with fractions and variables on both sides, and it's going to get pretty hairy and crunchy. But let's just start probably with the most basic type of one-step equations. Are the ones that all right. So the reason why that these are called one-step equations is that it only takes one step to solve these guys. So again, this right here means 2 times something equals 10. 2 times what is 10? Well, you could just use guess and check. Oh, 2 times 5, right? So we know that x equals 5, right? So that answer is correct, and then we're done. But what I'm interested in is showing you the math behind it, like how do you derive x equals 5? And the reason why that you need to know how to do that is when we start doing these hairy, crusty, crunchy problems, which take like 3 to 6 steps to do, you're not going to be able to do guess and check, right? Like you're going to have a methodical, procedural way of doing this. So let's just start off with the easy one, start with the procedures, and then do step 2 with procedures, and so forth. Okay, so that's kind of how I want to head here, is not just do guess and check, but just start with how to do it mathematically here. So 2 times x. Okay, so check this out. If I asked you what are the opposite operations, I can't fit that there. So the opposite of adding is subtracting, and the opposite of subtracting is adding. And the opposite of multiplying is division, and the opposite of division is multiplication. Now, this is actually extremely important for when you solve equations. You say, well, what do you mean? Well, check this out. I'm always going to ask the question, what operation is it doing? And what is the opposite? I'm going to write that down right here. So what is the operation? What is the operation doing? And then secondly, what is the opposite? This will be extremely important here when we start to do these guys. Alright, so this will be important right here too. Oh, cool. I like little arrows. Alright, so we're going to use this a lot here. So check this out. This is how it works. And if you already know this, sorry about that, but I'm just going to go through this anyways. Okay, so this 2. What operation is it doing? What operation is the 2 doing? Is the 2 being added, subtracted, multiply, or divide? Well, it's being multiplied, right? Again, this means 2 times x. So what is the opposite of multiplying by 2? Well, dividing by 2. So that's what you do to both sides. You divide both sides by 2. And what I mean by both sides, meaning both sides of the equal sign. Because the equal sign means that the left side is equal to the right side. We want both sides to be equivalent. Equal. All right? So check this out. 2 divided by 2. Those cancel out. So all I have left is x. Drop down the equal sign, and 10 divided by 2 is 5. Okay, so we knew it was 5 in the beginning, but this is the way that you can solve now using this whole opposite operation majigger. Okay, let's try it over here. What operation is the -6 doing to x? Well, it's being multiplied. So what is the opposite of multiplying? Dividing. Now again, I'm not saying what's the opposite sign. Okay, I'm not saying no. What's the opposite of multiplying by -6? Well, dividing by -6. Okay, we're doing the opposite operation. Okay, and I'm just going to draw my little dotted line right here so that we have things balanced. Those are gone, so x equals -30 divided by -6 is 5. Whole bam. So check this out right here. You say, oh, okay, this may look a little more weird, but check this out. All right, so we know that the 1 is being multiplied and the 5 is being divided. Okay, 1's on top and the 5 is being divided. So check this out. The way that this works is actually this. Let me just go to this. When we have a fraction multiplied by a variable, so this is our coefficient, we are always going to multiply by its reciprocal. So I'm going to multiply by its reciprocal. The reciprocal means you take the denominator and put it in the numerator, and take the numerator and put it in the denominator. So I'm going to multiply by 5 over 1. but make sure you do it to both sides so that it's balanced. You say, well, why are you doing that? Check this out. 5 divided by 5 is 1, and 1 divided by 1 is just 1. So really, this whole thing just became 1. So I have 1x, or just x, equals, and now we multiply straight across. Negative 2 times 5 is negative 10, and then you have a 1 on the bottom, but we're not even going to pay attention to that. Okay, how about this guy right here? 0.6y equals 7. So if you're using a calculator, you can just say, okay, I'm going to divide both sides by 0.6. Oops, I'm not going to do that though. Let me get rid of that little negative sign. 0.6. So those cancel out. So y equals, so if you use your calculator, it's going to be 11.67, rounding that up right there. Okay, but say if you didn't use a calculator, for those nerds to the max, one way that you can do this is you can turn 6 into a fraction, and 0.6 is 0.60 or 6/10. So you can say 6/10 y equals 7. And again, based off of the example that we did up here, remember, you just multiply by the reciprocal. So we can multiply by the reciprocal. So the reciprocal of 6 over 10 is 10 over 6. So you would multiply by 10 over 6. So those guys cross out. So so y equals 70 over 6. But you know, these, they have a common number of, let's see, probably like 2. So that would be 35 over 3. And we would leave it just like that. I mean, we don't have to put it into a mixed number. That would be great right there. All right, moving on to E, 3/4 a equals 9 over 5. So again, a fraction is multiplied by a variable. So we just multiply by its reciprocal. By 4/3, by 4/3. Haya, haya, hoyo, hoyo. And again, I always like draw my little line right here because I have a left side and a right side. So I have a equals, now watch this. I'm going to first simplify before I cross multiply. So I see that 9 and 3 have a common number of 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. So 3 times 4 is 12. 5 times 1 is 5. And so A is 12 over 5. Okay. Lastly over here, 16 times x. I'm going to divide both sides by 16. So x equals, let's see, 1, 3, 5. Okay. There was a few other examples I was going to show here, and maybe I'll just do like a part G now or something like that. So here's G. I forgot to show you ones about addition and subtraction. Say if I said k plus 3 equals 15. What number plus 3 equals 15? Well, we know it's 12, right? 12 plus 3 equals 15. But what's the methodical, what's the algebraic way of solving this? Check this out. What operation is the 3 doing? Well, it's being added. So what is the opposite of adding 3? Subtracting 3. Very good, Billy. So we're going to subtract both sides by 3. Okay, because we asked the question, what operation is the number doing? And then what's the opposite? So those are gone. I get k equals 12. Let's do one more here. Scroll down and get some more room. So say if I had negative 3 plus x equals negative 21. Okay, so I want to get rid of this negative 3, right? So negative 3 plus x equals negative 21. So what operation is the negative 3 doing? Well, yes, it's true that negative 3 is being added to x, right? Okay, that is true. But we're not going to subtract 3. You say, well, wait. You're supposed to do the opposite. Well, check this out. The goal is to get rid of the negative 3, right? So if you look at negative 3, well, the opposite of subtracting 3 is adding 3. And actually, that's what we want to do. We want to add 3 to both sides. It wouldn't make sense to subtract 3 because if I put a minus right here, then that means I would have done negative 3 minus 3, which is negative 6. And now I didn't get rid of this. I want to get rid of this so that x is by itself. So, those are gone. And I get x equals negative 18. Okay, one more example here. Check this out. I'll make this, this is Well, actually, it's going to be a two-step. Actually, we'll just stop right there. So those are a number of one-step equations because it took one step. You do one thing to both sides to get our answer.